I'm really grateful to be here, to have this opportunity to participate and discuss things with you, because as you will see, there are a lot of aspects on which the work I have been doing and Dr. Kerr has been doing too are converging, right? There are interesting convergences at different levels. So I hope to be able somehow to disentangle these levels of convergences in order to be able to make the most of the kind of evidences you and me and other people around the world have been collecting, looking at the phenomenology of this kind of complex diseases, complex behaviors, complex dynamics. So let me share my presentation okay. Okay. Is it, let me put maybe also in, is it okay for you too? Okay, perfect. Thank you. Thank you very much. So okay, no, it's, I probably have to, okay. I will keep this mode because, yeah, I need to move forward with at my speed. Not, technology is not helping always. So the idea, the topic, the main issue I wanted to address today is pretty much related with the evolution of the explanatory models of cancer. Why I have been interested in the models, in the explanatory models of cancer, and mainly, and as Dr. Kerr already said, in the origin models explaining the origin of cancer. So looking for causes of cancer. There are at least 3 reasons. The first one is related with my viewpoint, my privileged viewpoint, which is looking at things from the point of view of the scientific practice. In this talk, I will thus move from the assumption that the philosophy of science in practice means both scientific practice and the functioning of science in practical realms of life. If we are interested in exploring the assumptions and methods underlying the sciences, we need both to explore the theories and results produced by scientists and the processes by which they come to these conclusions. Assuming, as is common in scientific practice, that providing an explanation of an outcome is to some extent providing information about causes. Let's also read this other slide. So the strategy is that rather than asking general theoretical questions about the appropriate scientific standards for evidence, recasting the question of interest in terms of activities allows us to explore various approaches to the generation and weighting of scientific evidence. Therefore, the object, the complex character of most pathologies and difficulties in representing and explaining their features and behavior is at the core of our work. A pressing question concerns the adequacy, in fact, in the scientific field already, and also in the philosophical one now, of molecular biology and systems biology to account for complex diseases. In the philosophical scenario, the discussion has been largely focusing on whether the features attributed to mechanistic models by the new mechanistic philosophy can adequately account for explanatory models in biomedical or on multi-level and integrated approaches in biological sciences. Okay, these 2 slides might seem a little bit complex themselves, talking about complexity, but I think that the very simple, I think, point is that if we trust science, if we trust human activity in science, in clinics, we really see how and why explanatory models of these complex diseases are changing, are evolving, and what kind of new insights, which are not only practical but also theoretical, emerge from this process. I'm saying this, I'm stressing this point because I think, and maybe we will go back to this point tomorrow in the other session, that one of the most interesting things is nowadays, from very different disciplines, and here and now in this conference, we have a very nice example of this. There are intuitions that are supported by evidences. And through evidences, we are able to develop a scientific narrative, to develop a scientific model, to converge and to agree upon the kind of evidences that are relevant and what kind of explanations are really adequate in order not only to explain, but also to treat this kind of diseases, which was precisely the point that Dr. Kerr made at the very beginning of his presentation. Now, today, in the next half an hour, more or less, we will be very focused on the biology of cancer, but from this point of view. So the first question we have to ask ourselves, and that's what the question that people asked themselves decades ago now, when the president of the United States declared the war against cancer, and the language was very interesting at that time already. The idea that cancer was to some extent complex was already there. But at that time, we also knew a lot about genes, about molecules. We were developing technologies in order to go deeper and deeper in the biological organization of living systems, and of course, of the organism. What is cancer? Does anybody recognize this picture? I like this. It's Kandinsky, and it's interesting. Quite often I use this picture in order to talk about cancer, because I think that in this picture, the overall picture is saying something, but when we go into the details, there is no way to say what it is. Okay, so we have a feeling, an intuition that there is a unitary idea, but all the pieces, if we look at the single pieces, it's just a mess. So, and cancer is pretty much like this all the time, challenging us, challenging biologists, challenging physicians, right? In different ways, but more or less giving this kind of image. So the attempt in science, because of the definition about explanation and causes I presented above, the attempt and the goal was to offer a simple definition of cancer. As always, in clinics, right, in medicine, when we are able to offer a simple definition of something, relating something to a very concrete, specific cause, usually we feel much more secure in using a specific treatment, in offering a specific process to the patient, to the family of the patient, to society, to address and to manage with that specific disease. And the same happened for cancer. What is cancer? If we can define cancer, we can make major decisions in clinics safely. So at that time, the idea was that solid tumors, but mainly all tumors, arise from an alteration of cells, genetic material, causing it to respond differently to the host's growth regulators, and this leads to the uncontrolled growth of these cells. The famous book, The Selfish Gene, does belong to this kind of tradition, to this kind of understanding of cancer. But clearly, that was not the whole story, because immediately it appeared, it was clear that cancer was a complex phenomenon. When we started looking for genes, when we started looking for specific molecules involved in a specific tumor, we have been collecting thousands of molecules. So at the end of the day, that was not so simple to define, to offer an essential definition of cancer. As you probably know, now in clinics in biology of cancer, there is also a trend to give up with this goal of offering a unified definition of cancer. And in some hospitals, they are even talking about different kinds of cancers as if they were different diseases. But in the practices, we are still calling all those diseases, quote unquote, cancer. So there is still an open question about what is cancer, right? So at least it is fair from a scientific point of view, from a clinical point of view, to continue asking ourselves this question. From an historical point of view, what we know, what we learn from the biology of cancer is that at the very beginning, 2 centuries ago, more or less now, cancer was defined as a problem pretty much related with the environment. At the beginning of the last century, it was defined in cellular terms, and it became a genetic disease when we discovered the DNA. What is interesting is that once we reached this genetic period, in the biology of cancer, there was a different trend that rediscovered to some extent the relevance of the environment, but not in the same way it was understood at the very beginning of our scientific study of cancer. What I mean is that in the field of the biology of cancer, 3 different research programs started and are continuing at the same time. One of them is still looking at the genetic level, at the molecular level of neoplastic cells, cancer carcinogenesis, and so on. Another one is looking at the cellular level, cancer, is focusing on how those specific cells behave. And there is a third trend, which is much more interested in like Mina Bissell, as Dr. Kerr said already, presented, right? Much more interested in the role of the tissue, of the architecture of the tissue architecture. What is in common and what is behind all these 3 research programs? The evidence, and I'm talking about scientific, empirical evidence, that in any case, sooner or later, cancer is affecting all the levels of the biological organization. No matter where a cancer starts, if it develops, it's compromising all the levels of the biological organization. And that's why we have, for example, cancer and not diabetes in beta cells or pancreatic cells in some cases, right? Neoplastic cells are not merely losing a function, but because they are losing a function and they are no further functioning in an integrated way in the specific functional context, emergent functional context, sooner or later, they stop behaving properly, talking properly with the other cells, and they get lost in their own biological setup, genetic setup, which is changing all the time. So that's why we say sometimes that the neoplastic cells are like crazy cells. We will go back to this point because it is very much related with the differentiation issue that Dr. Krell already stressed, and which is so important in the kind of relationships we are looking at, or convergences we are looking at here. From a clinical point of view, I would ask, because I'm pretty sure that many of you can answer this question. From a clinical point of view, how do we diagnose a cancer? We still diagnose a cancer despite all the technologies we have, no matter the kind of level of molecular detail we can get into looking in the specific cells, neoplastic cells, tissue, blah, blah. We still diagnose cancer looking in the microscope. So it's a human observation of what? What a physician, what a pathologist sees is a disruption, disorganization, disintegration of an organized, of a previously normally organized tissue. When we have a normal tissue, on the left, we have clearly a heterogeneity of structures, but that are well organized in functional terms. In the neoplasm, we cannot recognize a structure, an order. Something went wrong, and there is a sort of homogenization of all the elements. When we were looking for genes and for molecules, we were asking or assuming, let's put it this way, we were assuming that cancer was pretty much related with an alteration, so a specific event on a specific gene, which was molecularly defined. So the typical genetic mutation. It's important to acknowledge here that the causal story is related with a specific event that took place in a specific moment, here and now, right? So it can be historically precisely defined. And we have been collecting how does differentiation happen, right? Or the differentiation in the case of cancer happen. We started with and we still use in many cases this kind of narrative of looking at the neoplastic cells as cells that were normal, and because of a mutation or a bunch of mutations, at some point it became neoplastic. So uncontrolled proliferation and metastasis. Possibility, capability of moving around without any control. The consequence of this was that the scientists were aware, very soon became aware, that this was too simple. And they started adding other, they say that this result was even simpler than we reductionists had dared to hope for. The idea here is that, let me also make explicit this point, science, empirical science, experimental science, does work through reductions. We are used to study the composition of things, of the organism, and to put things into relation, right, in different relationships, and to develop a narrative, an explanation based on this kind of evidences. And this is still work. Probably it will be clearer tomorrow at this point. But what I'm interested now is in saying that when we instead talk about reductionism, we are referring to the attempt of explaining everything in terms of the parts, avoiding any reflection about what is happening at the higher levels and what kind of effect of causal impact a higher effect can have on the lower levels of the organization. So this was something reductionist people, in this sense, were already aware at that time. But as it sometimes Dr. Kerr, in his presentation, at some point said, it's obvious, it's clear why we don't understand it, right? Quoting somebody, right? And this is, in fact, the case all the time, because human beings behave precisely like that, right? We have evidences, but it takes time to change our mind, to open our mind, and to try to looking at things in different ways. And clearly here, we have to look at things in a different way. Why? Because if we have a relevant question, like the one we are addressing here, why is this the case that when I'm looking for one gene explaining everything of cancer, I'm collecting all the time more and more genes and molecules that are at the end of the day involved in the genesis of cancer? The question is relevant, but if we continue using the old framework, so we are linked to, let me put in a philosophical way, it's probably clear enough. We transform a methodology in an ontology, in a way of understanding the world. The methodology is fine, but if we think that molecular stories are all the stories, able to explain everything, we cannot see things from a different point of view. And this was the case at that time. People looking in this kind of research program were collecting this kind of evidences. They added other levels and layers of moleculars, in this case, genes, other genes, epigenetic factors, and so on. And they came up reconstructing the whole picture of the cell. So as you can see, this is obvious. It's then when we tried to simplify something, decomposing it, and in the effort, in the process of explaining it, we reconstruct the whole picture. We are not able to explain anything. Okay, and this is I always use at this point a quote from Einstein that was who was used to say to his students, make things as simple as possible, but not more. Okay, so this is part of the story I was interested in representing here. Obviously, I'm simplifying, but what is also interesting is that these people like Weinberg, Robert Weinberg, who is very famous and very well known, is very honest in recognizing, and this was a very short article he wrote just with his name after decades of research on cancer, saying this, right? Coming full circle from endless complexity to simplicity and back again. But what's interesting in this article, I would encourage you to read it. It's very short and it's easy to find it and to read it in internet, is that Weinberg said, so perhaps ironically, we have come full circle, beginning in a period when vast amount of cancer research data yielded little insight into underlying mechanisms, to a period when a flurry of molecular and genetic research gave hope that cancer really could be understood through simple and logical reductionist thinking, and finally to our current dilemma. Once again, we cannot really assimilate and interpret most of the data that we accumulate. And this is the most interesting part of the article, because he's acknowledging that the real problem is not the lack of data, is that we don't have the adequate framework to interpret them. So we cannot move forward. And he says, let's hope that the future generation will take over the challenge. But let's go back to the work of this kind of people that are very good scientists, right? As always, we have to trust science, science and scientists when they are honest enough to acknowledge when we get stuck, right? At some point in our attempt to explain something, to deal with the complexity we are facing in degenerative diseases. And cancer is clearly a degenerative disease, as immuno-related diseases or neurodegenerative diseases are. They, at some point, they stopped looking or thinking that specific genes were like P53, CRB2, right? These names that we are used to hear, because it's quite common, right? To say, well, I have inherited this kind APC for colorectal cancer and so on. So they stopped talking in terms of pieces of DNA, and they started almost without realizing it, I think, using a different language in the effort of explaining carcinogenesis. They started using this language of functional capabilities. They organized genes thinking of their functional pathways, of the functional pathways in which they were involved. And the kind of image they came up with is this one. This is very well known. I think the hallmarks of cancer. They started with these 6. They became, again, for the same dynamics I illustrated above. They became 20. They became, well, now they are many, right? But the intuition here was very interesting, in my opinion, from an epistemological point of view. They recognized, they were able to reorganize the pathways, the functional pathways involved in carcinogenesis, mainly in 6 categories. And these categories were resisting cell death, sustaining proliferative signaling, evading growth suppressors, activating invasion and metastasis, enabling replicative immortality, inducing angiogenesis. Okay, so the idea here was that tumor cells were characterized by this kind of capabilities. Let's make explicit another interesting point, which was a consequence of that initial methodological, but also ontological, in my understanding of things, way of looking at things. If we think that the problem of cancer is the cell, we develop a narrative of the disease saying that the cell, in my publication, I often use this expression using active verbs. I say all the time that the tumor cell is doing, the tumor cell is avoiding, I'm using this kind of language, right? So the active, the tumor cell is the cause of its own behavior. The reasons of that behavior do belong to the cell itself, by definition. Of course, when we look at things from this point of view, the obvious and logical kind of treatment for cancer is what we know up to now, right? Which is still the common practices in the hospital. We mainly try to kill the neoplastic cells. Okay, that's obvious if the assumption is the assumption I have been illustrating up to now. More than 10 years ago, I tried to reorganize this kind of functional capabilities, looking at them not from a cellular reductionist viewpoint, but from a systemic point of view. And if we reorganize those 6 processes, those 6 capabilities in 4, because we can assume that the migratory capabilities of cells are pretty much related to proliferation, blah, blah. I don't have time now to expand on why I have been able to reduce to 4, and maybe we could reduce to 3 or to 2 proliferation and differentiation processes, right? But we can tell, or we can have 2 different narratives, depending on if we look at the cell or if we look at the behavior of the cell from the point of view of the context of the macroenvironment. If we look at the cell, of course, we have to say that the cell become able to, right? We have to use this kind of language. But if we look at things from a systemic point of view, we can explain the same kind of evidences in terms of parts, elements of a system that are losing feedback on control, dependence from capability of. And this is not just a matter of language, it's a matter of framework, of theoretical framework. That was precisely the shift that the turn, right, that also Mina Bissell and many others, like in the last book that Caroline was mentioning, is Rethinking Cancer, are stressing. There is a important radical change in perspective that is opening up new ways of understanding things and intervening. We can intervene in different ways. And we can also understand much better why in this kind of diseases, prevention is fundamental. And why and when it is not incompatible with other more traditional, quote unquote, or established, quote unquote, therapies. I'll probably go back to this point by the end of my presentation. So if we ask the question of, at this point we have elements enough, I think, to ask the question, what is cancer in terms of what causes cancer, right? What does cause cancer? What are the causes of cancer? We can say that, of course, we have to acknowledge that there are a lot of causes. There is a multiplicity of causes, because sometimes cancer is very much related with genetic, like retinoblastoma. In retinoblastoma, it's clear that there is a genetic factor that is affecting the organism and that is responsible for cancer. But there are also environmental factors. We still have to acknowledge that in specific kind of environments, cancer is more frequent than in other environments, context, professional workplaces. And there are plenty of examples. But what is also evident is that the striking heterogeneity of the tumor cells within the same tumor, within the same cancer, and among cancers of the same type in different organisms, in different patients, is still challenging us all the time. And this kind of heterogeneity is not a noise in engineeristic terms, right? It's not something we can reduce. We were struggling for decades, right, in the effort of finding a unified story of cancer and looking for the molecular involved, the cause involved. but there is no specific or unique molecular involved. I'll go back if you're interested in the example of retinoblastoma, because if it's true what I have said about retinoblastoma, and it's also true what I have just said, that there is no specific molecular cause of cancers, right? It seems to be a paradox, an oxymoron, right, at this level. But this is not the case for a very concrete reason, which is epistemological, philosophical, but also scientific. I think that is now, that can be now much more, that can be clearer now. I'll go back to this point. Let's continue at the moment thinking what is going on in the biology of cancer field. If we have to face with this kind of a scenario, so a multiplicity of causes and a huge striking heterogeneity, we have to make a decision about is reductionism a good way of looking at things? Is still looking for mechanism an interesting way to address and to face with the complexity of the neoplastic processes, right? Let's try to answer, to offer a different level of answer to this question, looking at now more the explanatory stories that have been offered, right? In the reductionist field, I was representing above with all those images of cells, genes, epigenetic factors, blah, blah. The story goes like this. We have a normal cell and we have an event, a specific historical event, a DNA mutation that is responsible for the neoplastic transformation. Some people at some point started rethinking the kind of evidences they had in their laboratories, Mina-Bissell among others, and some evidences already, Dr. Kerso, thank you again, because you already anticipated things that I don't need to repeat now. But some people started thinking in these terms and say, look, let's look at the context, let's look at the tissue, and let's consider the possibility that instead of talking a story based on cellular behaviors, we can look at a normal tissue and say that what is altered is the organization and not a specific piece of matter, right? It's not a problem of a specific brick, which is functionally destroyed. It's the overall organization of the structure of which the cells are parts, of course, that is compromised. And if we go that direction, so stressing the tissue over time, so it's not enough one event. We need time. Time becomes important. And time is very important in this kind of diseases. We do know now that, as Dr. Kerr already said, that cancer is not a problem of having a cell behaving differently, not even of having a neoplastic cell here and now in my body. We develop cancer every day, but not because of that we get cancer, right? For that, time is needed, and a very specific kind of time, which is a beautiful topic to develop if we will have time today or tomorrow, okay? This is not a physical time. This is what I'm saying. Let me just give you, maybe it's just an insight at this level, but the kind of time I'm talking about, which is something I'm studying in these years now on cancer and other diseases, is not the physical time, the variable t we put in the equations, right, in physics. It's the organic time, which is much more related with rhythms in our body, of the specific organs. When we compromise because of stress, because of environmental factors, because of hormones, because of other factors. This kind of ordered rhythm of our body, we are destroying, compromising the music of our body, which can be described at the cellular level more and more. There are empirical evidences about it, this in terms of metabolism, in energetic terms, in genetic terms, and so on. So the image that is emerging is beautiful, because the image is a unitary image where different narratives and models are allowed. They are not incompatible. They are looking at the same kind of dynamics from different point of view, but all of them are systemic, definitely not reductionist. In a systemic framework, there is a space for a pluralistic approach. And especially, which is even more important, I think, Dr. Kerr, this is a question for you, for what we should consider a personalized approach. All of us, right, we are different. There are some things that are in common, but each of us needs a different approach, probably. But this does not mean giving up with a unified understanding of the disease itself. I have found something about this, Dr. Kerr, in the last chapter of the book, I think, but this is a question for discussion later. Let's move forward and say, what is in between these two theories of cancer, right? Two explanatory models of cancer that are radically different, in my opinion, in epistemic terms, is a question that in the reductionist area, from the reductionist point of view, seems to be a paradox. While it completely makes sense in the systemic viewpoint, when we manage the cancer through tools, epistemic and methodological tools that are typical of systems biology. We know how to generate a cancer, but we do not know how to explain it. If you say, if you make this statement in a laboratory, they think you are crazy, right? Because if you are able to generate something, if you are able to do something, by definition, within the reductionist framework, we are able to explain it. But this is not the case when we face with this kind of complex diseases. So there is something different in the understanding of the disease itself that can allow us, from a scientific point of view, to make sense of a statement like this. People looking at things from this point of view, like the authors of the TOFT, the tissue organization field theory, starting looking at the kind of evidences that Dr. Kerr already represented and reported, so I don't need to spend more time on this. What is probably interesting for the discussion is that an assumption which is radically different in the two approaches, so the SMT, the somatic mutation theory, and the TOFT, the tissue organization field theory, is that if you think of the language I was using, right, the active verbs describing the behavior of the cell, or looking at the behavior of the cell that is no further constrained by the organization of the tissue, the assumption, the biological assumption about the cell is very different. Because we are assuming in the first scenario, the reductionist scenario, we are assuming that the cell is by default quiescent. They are very quiet, and at some point they start doing something in the process of proliferating, for example. Proliferation is something that starts at some point. From the Toft perspective, from the perspective of an organizational field theory of cancer, the assumption is the opposite one. The assumption is that all the cells in our body are proliferating all the time if there is no factor, contextual factor, macroenvironmental factor, that is keeping them quiet. Okay? So now, if you start thinking at cancer from the two different perspectives, it's very interesting. When Dr. Kerr said we should not think of this kind of disease as a problem of the individual, right? But of a problem of the context in which the individual lives. The assumption about the individual behavior itself changes. And helps in looking at things also at the kind of treatments, right? The kind of intervention we can use, we can adopt differently. Because we are acting not on active behaviors, but on the constraints that usually regulate or make it possible for those specific behavior to be integrated in a, let's use this language also for the cells, a social context. Okay, let's move forward. So the two opposite views, right, of the organism at that point became organicism and atomism. In the reductionist scenario, we were used at the end of the day of thinking of cells as a autonomous players. They were responsible for their own behavior. They were able to do things, to manage better and to move around without any kind of constraint, being able to overcome boundaries. When we look at things from the point of view of organicism, instead, we look at those behaviors as pathological ones because they are no further constrained. They lack the possibility of being integrated, functionally integrated. So proliferation and differentiation, the uncoupling of these two processes, which can be actually reduced even to one, which is in fact a differentiation, is crucial in understanding the kind of imbalance, the dynamic imbalance that is taking place in cancer. And it's interesting listening at Dr. Kerr using the language of attachment, emotional attachment, when coming to this point of blocked ontogeny, right? Because a blocked ontology, which is precisely what happened in cancer, when we look at cancer from this systemic point of view, is a detachment of cells from other cells and from their contextual, historical, biographical constraints. And what is even more interesting, let's see, I should have a slide on this point, and I would really like to move immediately to this point. Let me skip at the moment the point of field of cancerization. I'll go back to this point later. But to follow now the flow, right, of this way of reasoning, we have to acknowledge, this is an important point, I think, that the kind of heterogeneity of tumor cell is very much related with 3 dimensions that are always in place in the integral development of the organism, so in ontogeny, and also in my understanding of things in the organizations, social communities, and so on. Which are these 3 dimensions? Let's look at the pathology. We always learn a lot from the pathology, right? From the pathologies about the physiology. It's really difficult to study the physiology itself directly. We learned always, no, since ever in the history of medicine, a lot from pathologies. What we learn from cancer is that the kind of heterogeneity is tumor cells are evolving like this, like we see in this picture. We have a green cell, a normal cell, at some point starting behaving differently from a functional point of view. So the functioning of those cells is no further integrated. But what happens, like in the example I gave at the beginning, like beta cells, pancreatic cells, is not that we have diabetes, which is a functional disease, but we get cancer because those cells, because they are no further constrained for a long time over time, they start losing the capability of keeping their genomic setup organization functioning as a unity. So the genome, as it is not able to function as a unit, start changing over time, all the time. And that's what we call the type 2 of tumor heterogeneity, which is related with, it's not merely aberrant differentiation, is that those cells move forward towards different offspring all the time. They are changing their biological identity. They are losing the capability of keeping their biological identity constrained. And that's what is cancer about, right? What is interesting is that if we look at the famous genes we were looking for at the very beginning, decades ago, blah, blah, we have been able to find two different classes of genes, mainly the gatekeeper genes and caretaker genes. Let's focus on this as a case study. We don't have time to go deeper in the landscape gene, okay, at the moment. Gatekeeper genes are the genes deputed to the communication among cells. Caretaker genes, instead, are the genes deputed to the maintenance of the genome structure, to the genomic stability, okay? When to get cancer, it's enough a mutation, an alteration among within the group of the gatekeeper genes, while we need two mutations on the two alleles, right? The caretaker genes plus one in the gatekeeper genes. So it's not enough a mutation on those constraints at the genomic level. What we need in any case is an alteration of the communication among cells. But what is even more interesting from my point of view, understanding the ontogeny, right, of the living beings, is that from an evolutionary point of view, the story goes the other way around. From an evolutionary point of view, the first genes to appear were the caretaker genes. What I'm saying is that when we look at the organism as a unitary entity from a dynamic point of view, what comes later in temporal terms becomes more relevant in causal ontological terms. The lack of constraints, compromising the capability of cells in the communication, in the tissue organization, in the society of cell, compromise the possibility for the single cells to be stable from a biological point of view. So you can see how many things, right, are changing if you look at things in a different way. And this explains why the emphasis, I'm going back to the two slides that I have left. How does differentiation happen, right? We go back to this question from a systemic point of view. We stopped adding elements to the narrative, genes, other molecular, other epigenetic factors, blah, blah. We started to talk about in terms of fields of cancerization. The common idea is that in cancer, the functional stability of a field is compromised, and that this notion of field concerns functional definition of parts and parts stability as well. This is, I think, an important point. Now, I think that, wow, it's already 1 hour. Caroline, I can stop here because I have some, maybe 2 other issues here, but I can stop here. What do you think? Because
we have a half an hour left, so we could. You want to take about a few minutes to see if there's any questions or comments, and then go ahead and move on. Does that work? Okay. Yes. So if you would like to ask a question, please raise your hand. I don't even know where to start. I have so many questions.
Dr. Kerr was much better than me, therefore, in explaining things.
Professor, I think we may have to get out of the share screen mode in order to have anyone be able to. Thank you so much. Anyone, if you have questions, now's the time to raise your hand at the bottom using the little reaction, the little smiley face at the bottom. Okay, Joan, would you like to go first? Joan,
yes, Dr. Berlosa, thank you so much. I do have a lot of questions, but I'm just going to make one comment and see if I'm on the right track. I think what you're saying is when you look at the organism as a whole, you're seeing something quite different than somebody that's just looking at the gene. And it's not that easy to, it is a system, just like the family, just like Dr. Kerr was talking about. It operates as a system in terms of one thing reacting to another thing, and then a response back. And I guess one of my questions is, well, am I on the right track? And what is your thinking about how relationships in the environment impact the body?
Yeah. Okay, thank you. Karen, do you prefer to collect the questions or to answer? Do you want me to answer?
Go ahead and answer. That'd be fine. Yeah.
Okay. So thank you again, John, for the question. So I think that I'll try to put it simple. The point is that the body is reacting all the time as a unity. So this means that there are dimensions of our body, of living organisms in general, and of course of human beings, that are able, in literature, you can read this expression, there is a lack of time scale reactions. So you have, although in different ways, reactions at different time scale levels of the organism. So you have, if you have an input from outside, from what we consider outside, at the genomic level, at the epigenetic level, at the level of the metabolism, at an energetic level, at the level of hormones. This means that depending on which level is the weakest in that specific moment, you will have a reaction at that level that if is stressed over time, is able to compromise all the other levels at some point. And that specific point depends pretty much on the integral dynamic, on the robustness of the dynamic unity of the organism itself. So to me, we should move forward, and this might be the next step. In my understanding of what Dr. Kerr said and the reading of his book is already going that way, that direction, is that we should understand differently also what we call external factors. As we should understand differently, this might sound now as I don't want to be provocative, but saying that we should understand differently the very notion of gene, or even better, the very notion of biological information. Because we have been used to think of biological information in mechanistic terms, in terms of byte, right? Of specific events happening, occurring in time. But here the problem with a systemic vision, understanding of things, a unified understanding of complex degenerative diseases, is that what is relevant is not what is happening here and now in time. What is important is the biography, is what is happening over time. And time is important. So to me, and I'm saying this because I think that there are a lot of evidences we have been collecting, looking at genes, that we are just ignoring because we don't have another way of understanding them. If we look at this, if we reconsider the notion of biological information, we can even talk about the genes, again, in cancer, but with a very different narrative. I don't know if I say something relevant because your question was very wide and might require a wider answer too, but just to say something that might help. John.
Thank you so much. It made my thinking broaden what you said. Thank you so much.
Thank you.
Okay, I think we have two other hands I see.
Eric Thomas, or Eric Thompson, excuse me, I'm sorry. You can go ahead.
Thank you. Dr. Bartolosa, I feel that I've been listening to music.
Because of my Italian accent.
No. It's because of the joy you have for your subject and the clarity of these bold ideas. And when you said there's a difference between time and timing, I don't think I'll forget that. Time versus rhythm. And you said that the cancer cell becomes detached from its biography. So in the Bowen theory, the treatment involves helping the individual family leader become more clear about the biography in a very specific way, in a systemic way, not very different from the Freudian approach. And I just think there's a fascinating parallel there. My question is about toxic workplaces because I work on the level of business organizations. You mentioned that there's data about that. Would love to hear any reference or a good book on that.
Yeah, that's something they are asking more and more. So I can send you some papers.
Okay.
Maybe, yeah, there is an academic paper in English. Definitely I can send you.
Okay.
In a handbook. That was just to give you another evidence of why it makes sense to have this kind of conferences, right? They asked me in a handbook of the Cambridge that was on philosophy of management to apply the epistemology I was developing in cancer to organizations. And it's very interesting, for example, just to give you a very specific, concrete, right, example of why it matters. Think of the traditional approaches in organizations in management.
Yeah.
The assumption, if based on the now old Tayloristic views, blah, blah, of organization, was that human beings were selfish, were selfish, right? They were looking for their own profit all the time. So the organization was the objective, the aim, the goal of the organization was to constrain that selfish behavior. When we instead look at organizations and why young people behave precisely like that, thinking and assuming that human beings in the first place are much more interested in building and contributing to what we can call common good, the kind of approach of human resources people, blah, blah, is completely different. And there are many other, right? Maybe we don't have time for this, but this could
well, it's based on a much deeper understanding of the systemic nature of the human being.
Yeah. Autonomy in human beings is relational by definition. When we miss this point, I think that we are missing something very important. And that's why now this is a quick, maybe too fast, but that's why, in my opinion, we are now worried about machines. We think that machines can do things in place instead of us in different contexts, right? And of course, we are building machines precisely because of that, because they can do better than us in functional terms, but they will never do anything instead of human beings in relational terms. When we think of things in terms of care, caring for people, caring for ourselves, caring for the environment is something that is beyond the possibilities of the functional activity of machines, because it requires, which is clear in cancer too, requires taking care of the language of by holding, right? It's not just doing things. I'm here. So because I'm here, as a mother, as a teacher, as a professor, as a colleague, as a friend, I'm contributing in maintaining that specific environment that brings information. And that information structures behaviors. And this is a semantic level. It's not a problem of doing things. It's a problem of being something, of being somebody. That's why biography, relationship within the family, within an organization, within a society are so important. Sorry, I don't want to expand on this.
Thank you. Thank you so much.
Thank you.
Carolyn, would you like to take another, should we ask?
Yes,
Robert?
thank you. Robert, would you go ahead, please?
Yes, thank you, Dr. Bertolosa. I had a question related to one of the last slides that you showed to see if I understand it well. You mentioned that caretaker genes evolved before gatekeeper genes, and that gatekeeper genes had to do, if I understood you right, had to do with the regulation of the genome. And then the gatekeeper genes have to do with the regulation of the signals among cells.
Yes.
So did that have to do with the emergence of multicellular organisms, that these gatekeeper cells emerged as a way of regulating the unity of this higher level organization? And I guess it's just interesting because, again, it would seem that in Bowen theory, again, the family is seen as a unit, and that there would be gatekeeping processes involved in the family. But is that, did I understand your...
Correct. It is correct. Yes, correct. Yeah, that's, yes. There is another class of genes that were the landscape genes that are related. There is a higher level, right, of organization in the metazones, precisely, which is the topological structure, the topological structure of the body. So the form of the body, Mina Bissell uses this language too, right? the form of the body brings a lot of information. It's not only the communication among cells, the gatekeeper genes, but there are also genes that are codifying for the form of the body, the topology of the body, the architecture of the body. And this is something that is when we destroy the kind of evidences that Dr. Kerr was already discussing, right? This idea that if I put a normal cell into a destroyed tissue, that cell sooner or later will become neoplastic. And if I put a neoplastic cell into a normal tissue, that behavior will revert. And it will revert not because genes, for example, go back to their previous structure. You have the same cells with the same mutations, but that do not behave in a neoplastic way. They go toward apoptosis, or they go back to a normal integrated functional behavior. That sometimes this is another, maybe I'm opening up another window, right, on the biology of cancer, but it's interesting. I think thinking of having in mind the book, right, the Bowen theory, the cells, all the living beings, do not have only one way to behave healthily, right, to be healthy. And in many cases, they are able to find new ways. That's why, in many cases, the effort of bringing the system back to a previous situation is not a good strategy.
Mm-hmm.
We have to help the organism to find its own way to be healthy, maybe in a different way. And that's the plasticity and the robustness of the organism as a unity. And I'm pretty sure that here, many of you have plenty of examples in mind. Practical examples, I mean, names and surnames. Sorry, I don't know if I answered your question.
Yes, you did. Thank you very much.
So, Dr. Bertolaso, would you like to continue on, or you said you had a few more slides you wanted to present, or is this a good time to?
Whatever is better for us. If there are other.
You have 15 more minutes before we actually are going to start the panel discussion. So if there's anything else that you'd like to use the time with for, I can do that.
Yeah, sure. Okay, so let me go back to the presentation. Okay. Okay. We are go back to the presentation, aren't we?
Yes, you're back.
Okay. Okay. So let me let's have a look at these two slides, because they will help tomorrow, probably. So what we have been saying up to now is that cancer can be better understood as a problem of imbalance. Dr. Kerr used the language of forces, and those forces are ordering forces, right? There is a order behind that allow us to recognize them as forces, combined forces. The same happens in the biology of cancer. What is interesting is that the spatio-temporally continuum of causal processes that are at work, so that no unique explanatory tool is either necessary or sufficient. Think that in scientific terms, in mechanistic terms, we have been looking, like I would say even in an obsessive way, to necessary and sufficient elements that once alterated, mutated, were able to explain the whole story. When we think in dynamic terms, in systemic terms, the picture is different, not because, and I know that probably now we are tired, but what I'm saying is important, especially for tomorrow, right? Is not in the sense that the genes, therefore, the cells, therefore, are irrelevant, but that we are differently able to understand in which sense, from which perspective, genes and cells are relevant. They do explain something, but that something might be completely irrelevant when we want to manage a degenerative disease as a whole process, as a unified process, as a unique process. I would really like now to ask you why the example of retinoblastoma is still consistent with the kind of discussion we are now engaging and we are sharing. If we said that the genes are not so relevant, right, in explaining cancer, but there are cases like retinoblastoma in which it's pretty clear, right, that we have a mutation, a genetic mutation on a gene that is responsible for a very specific kind of tumor, of cancer. Why are the two claims not incompatible? On the contrary, in my opinion, confirms the relevance of a systemic understanding of things. If anybody, but so let me make explicit my thesis on this point, right? The idea is that the retinoblastoma story within a reductionist narrative is should be, right, the general story. You have a gene, you have a mutation, you have tumor, full stop. But this is not the case. So there is a paradox, clearly a paradox. But if we think of tumor as a problem of communication among genes, and you look at where and how the retinoblastoma gene works, you realize that retinoblastoma is precisely related with a compromised talking, right, relationship among cells. That gene is precisely deputed to that kind of, to that level of communication in a very specific tissue, which make that gene enough in causal term to generate a tumor. Another example, another kind of evidence we can discuss at this point, but I would really like to hear from you, and Dr. Kerr already presented in the last part of his presentation interesting aspects, right, on this point of hypothesis of cancer. The regression hypothesis he presented, why we are we able to treat much better cancers related with blood, with the blood, in kids, in children, right? It's easier, in my opinion, it works. Tamoxifen, right, which is still one of the best drugs that are around in cancer therapies, in treatments and so on, works very better in those cancers because the blood is a very simple tissue. The topological architectural factors, dimensions, are not so heavy, quote unquote, like we can see or find in colorectal cancer, in breast cancer, and so on. So the to some extent, the communication among cells is not so much mediated, right, by architectural factors, like in other epithelial cancers. So this kind of evidences that seems not to fit, right, very well in the somatic mutation theory, paradigm models, and so on, fit instead very well and confirm a wider, different systemic understanding of cancer as a process, not a thing. Cancer is not a thing. Cancer is a process. So this is part of the impact, right? Is one of the clear impact and that can change our way of doing things in clinics. So let's use maybe a few more minutes to have a look at this slide. Here we have an abstract representation of the kind of stories and models we have been discussing up to now. On the left, you have the kind of narrative in a reductionist view field. So you have something that happens at the language is always very interesting. That's part of our work as a philosophers or epistemologists, right? The language is let's look for the most fundamental level of the disease in causal terms. And that search for the most fundamental is methodologically mediated. So the methodology was looking for genes, the methodology was looking for moleculars. So the fundamental was by definition genes and moleculars. And we came up with the picture we have been describing. We realized that there are other factors, John question and so on, right? That there are factors from outside, from the environment that are affecting the organ. And there is a lack of time scale separation among those dynamics. What I said a few minutes, already. Now the question is, okay, but again, if everything matters, how should we manage this thing? How should we address, right? How should we dance with this kind of pathologies? And it was a Nobel Prize years ago already, but as always, no, ideas come first and the practice is later. It takes time. It takes time. Said, okay, bottom up, top down. It's a problem in the practices. It's a problem of a middle out approach. What does this mean? We will go back to this point tomorrow. What does this mean? It means that in the practices, we have to do something at a specific level that we have been able to identify as the relevant level for the specific dynamics that are compromised. That's why in blood cancers, we can use tamoxifen just giving it to the patient, right? Without taking care of where it is injected and where it is moving and where it is ending up being effective. And in cancer, in breast cancer, in ovarian cancer, in other cancers, this is not the case. Because depending on the kind of dynamics that have been compromised, we have to choose the level that is relevant in order to keep the system constrained. So in some cases, it might be the case that we have to go back to the genes, like in retinoblastoma. It would be probably stupid, sorry for using this term, right? To, for example, to give the body something that is altering all the organizational structures of the body, because we are probably curing a cancer, but generating other cancers in other tissues, in other organs. If we have another, like in blood cancers, right? Or in other, it's the most terrible cancers, you know, are the anaplastic cancers that are asymptomatic completely. We have to act differently, because in that case, we really need a unified effort of the body in order to constrain differently everything in the body. And it's different, for example, to think in these terms for a kid, for a baby, or for elderly people, because the metabolism, the proliferative and differentiation activity of the cells is very different. So the kind of effect I can generate is very different. If I give differentiation factors, which is in fact the case in experimental tests in breast cancer, lung cancer, and so on, in the target are elderly people, it works, right? Because it stresses cells that are to some extent more active because no further constraint than other cells in the body. So the other cells are quote unquote safe from this specific treatment, but the same treatment in a child might have a completely different effect. I will be probably able to cure even more faster something, but probably I will generate other diseases because the metabolic activity of the body is different. So this idea of a middle out approach is something that machines cannot identify, right? Because this is a judgment. This is a judgment that does belong to human beings that are able to say what is relevant with respect to a specific scientific question. In some cases, it's important to act on the communication among cells. In other cases, for the organizations in the enterprises, companies, the same, right? It's important to work at the level of the communication among people. In other cases, it's important to change the architectural structure of the workplace itself. Think of all the problems we have now with the smart work stories. So this middle out approach is crucial in order to understand the importance of the epistemic activity of acknowledging where the dynamics are constrained in a right or wrong way in order to intervene in an efficient way. There are beautiful examples. Let me give one and I will stop because my time is over probably, Karen. But just one example, which is related not with cancer, but with another degenerative disease, which is Alzheimer. There was a team of physicians that were trying to identify a factor that was able to predict the disease. And they were starting collecting data about the functional activities of the different areas of the brain of people that for some reasons, because of the family, because of other factors, were potentially future patient affected by Alzheimer. And they were not able to find one parameter just looking at the functional metabolic areas of the brain, all of them, all the data available, no way, no insight about the possibility of predicting the disease. We asked, in my team, there is a guy which is very smart, a biostatistic here in Italy, and about working with people also in US, but so, as all of us. He came up saying, we don't have to look for one parameter. We have to look at the rate among the parameters. And looking at the rate among the parameters, we have been able to find a variable that was giving a 99% of predicting possibility of predicting the disease. So this is part of the message, right? When we think in processual terms, in terms of timing, we cannot look at things in terms of one variable. We have to look at rates. We have to look at the relationship among variables again. So even at a mathematical level, the kind of observables is different. Okay, I don't want to add more information because I think that we will lose Dr. Kerr. I think we will lose our participants tomorrow. They were tired, they will be tired and they will give up before starting tomorrow. I'm joking, but I'm pretty sure that you have much more examples than me in mind, thinking of your activity, your clinical activity, your even daily experience in organizations, families, and so on. I would stop here, Karen, if you agree.
Okay, thank you, Dr. Bertoloso. I'm sure you're running on time much later than most of us, so appreciate your energy and your effort to keep at it. So what we're going to do now is move into our live panel discussion. Dr. Kerr, and Professor Bertoloso and Mrs. Kerr is going to be joining in, and this time will be moderated by Joan Jerkowski, and hopefully we'll have some time now to really take a little bit more time to think and to ask questions. That's what's been offered today. So Joan, I'm going to turn it over to you. And if we can get,
Yes.
Ms. Kerr and Joan's picture up there, that would be great.
That's what I was waiting for. Is somebody working on that to show the panel?
Yes, I am. It's Shannon. Yep, 1 second. Sorry.
Okay.
I gotcha. Thanks for being
Okay,
here.
while she's working on showing the panel, I'll go ahead and get started. I was going to start with Dr. Kerr and then go to Dr. Bertoloso and then Mrs. Kerr, and then leave in some time for the audience discussion. So Dr. Kerr, I'll start with you.
Okay, I wrote down 17 things. And the only conclusion I've come to at the moment is that Bowen theory and Dr. Bertoloso belong at the same conference with certainty.
Amazing.
So many convergences, as you said, and so thanks for being here, or they're here. So I'll pass on that now, come back later.
Okay, Dr. Bertoloso.
I can I don't want to take a lot of time because I have been talking for 1 hour and something. So, but what? Thank you again because it's clear. But I would really like to listen, right? Also to concrete experiences that some of the participants should or might have, because from specific cases we can learn a lot, and maybe we can get even new insights. We have to take sometimes much more seriously, right? The concrete examples when we are able to put it in a wider theory, because there are probably important and relevant contributions that we can get out of them. Once say this, and so thank you again, and thank you for the comments or examples anybody here can bring into the conversation discussion, is the idea that if we take seriously the timing aspect, the dynamic aspect in terms of timing more than time, right? And we think differently, we understand differently the terms of biography, ontogeny, dependencies, constraints, attachment. We can really, probably, I think, develop a new epistemology about this kind of diseases. And epistemology, this strange word, in Italy, nobody is able to pronounce it properly, but they quite often confuse epistemology with epidemiology, which are two completely different things. So just feel free to mix up words, but epistemology is about the kind of evidences we are focusing on, what we are considering relevant in order to explain something, what we are looking at. And in this sense, I think that we can understand differently this notion of ontogeny, biological information, attachment, constraints, and so on. Because in a mechanistic culture, and not only science, because it's a cultural, philosophical problem, the very notion, the very term of constraint, the very notion of boundary sounds like a limit, like something negative. While instead what we are saying is that having limits, having boundaries, and being able to take over our own boundaries is the condition to develop, is the condition to be and to behave healthy. So just, John, I don't know, but just giving inputs and seeing if people is willing to contribute to jump into the conversation, also discussing things. I'm not saying that I have no final word, because there is a lot of work to be done here, clearly. So, for example, I would really like Dr. Kerr to hear more from you about this, which is not a tension in my understanding, but this relationship between individuality and togetherness in the Bowen theory. Because in my understanding of living beings, these two dimensions should be differently understood as the concave and the convex of a same identity, I would say. We can always look at things from an individual point of view and from the point of view of togetherness. So it's, and that's why, sorry, and I will be quiet afterwards. No, because I'm adding a lot of information, so really I don't want to stress people here. From even an Aristotelian point of view, the very question, the most fundamental philosophical interesting question, is not about emergent properties. Is why the whole is in some way present and represented in all the single parts. So this is a very interesting theoretical and scientific challenge. If anybody has any insight or reaction on this point, I would be more than grateful.
I'm going to go to Ms. Kerr next, and then I'll get the reactions of anybody else on the panel.
Okay, well, I want to thank Mike Kerr for inviting Marta Bertoloso, because this has just been a real treat. My mind has been exploding while I was listening to both of you. So I'll try to talk about the most wide themes that I have. Dr. Bowen used to talk a lot about how a family systems view was getting up at the top level of the bleachers and looking down on the family system from a wider point of view to see the interactions between the members. And I feel like Dr. Bertolaso has been up in a helium balloon above the top of the stadium looking down, which is just another treat. And then we have Mike Kerr's presentation, which is like going back and forth between the two. And then I hope tomorrow that I'll be able to present something that is trying to talk about bringing these ideas down to an individual occurrence of a symptom in a family system and in a work system. So that was one thought. Another was your comment, Dr. Bertoloso, on the war on cancer. I remember when that concept came out, I thought, good luck. Just good luck stamping out cancer, because my perspective has been cancer is going to always be with us. We might have more or less agency to deal with it, but that we're not going to be able to stamp it out. Another thought was the importance of timing. And again, I hope I'm going to talk about the importance of timing tomorrow. I hope I've concentrated on that in my presentation, and I'm hoping to convey convergence of a number of variables in a way that creates a perfect storm at a perfect time to discombobulate the physiology in a vulnerable person in the middle of a system. So I'm talking about cells in systems, but persons in systems. And several people mentioned, the last thing I want to say is, several people mentioned the concept of toxic workplaces. I think it's more complex than toxic workplaces, although certainly having the privilege to sit beside people and consult with them and consult with a number of people who have wanted to address their vulnerability in work systems. I think there are work systems that are more toxic than others. And I think that the work system I'm going to describe tomorrow at the point in time when I develop a system could be described as sort of toxic. But on the other hand, how was I vulnerable to that toxicity? How was I the squeaky wheel? Nobody else developed a life-threatening symptom in the same period of time. So I think it's a combination of head up, quote, toxic work systems and vulnerability of individuals within those work systems that can be best understood as interacting to potentially react with a physiological vulnerability in, if you will, psychologically, emotionally vulnerable individuals and potentially generate a symptom. I'll stop there. Like I say, my mind has been exploding as I've been listening.
Well, I can agree with that. Other comments from people on the panel, Dr. Kerr or Dr. Bartoloso, would you like to add anything?
Well, I was going to try to tackle what I think was Dr. Bartoloso's question. And I may be repeating things I said before. I guess I'm not sure. But the way I like to think of individuality and togetherness is the flexibility to move back and forth, appropriate and most adaptive to the situation. And togetherness can manifest itself in autocracies or selflessness. That for me was new experience with this current regression I think we're in. That there's so much me, you can't tell me what to do kind of thing. Anyway, I don't know if that's what you were asking, but I think it's the flexibility to appropriately move toward individuality or togetherness and having the ability to do that in an adaptive way. I don't even know if that's what you'd ask exactly.
No, yeah, thank you. Yeah, please, Kathleen, yeah.
Dr. Berlosa, did you want to say anything else about it?
No, I'm seeing that Kathleen is.
Okay, I saw that too.
Please, yeah, go ahead because I do prefer listening.
Well, this
Okay,
is
Ms. Kerr?
a question for Mike. Is that my understanding of individuality and togetherness is that when the individual and the system gets tilted more towards the side of togetherness without the flexibility to reach towards individuality, that more sort of like cancer cells, that more atavistic and primitive behaviors get activated that are not necessarily in the best interests of either the individual or the system. Would you say that's fair descriptively as you think about it?
Yeah, that atavism idea I think is real interesting that I talked about in my talk. The regression to far more ancient behaviors that technically could be overcome with a more thoughtful read of things. I don't know. What do you think?
Ms. Kerr?
Yeah, that without in a more regressed, more chronically anxious state, access to thoughtful alternatives becomes compromised, and feeling trapped in extreme either ors is more tuned up rather than the flexibility of more thoughtful processes, I guess is the way.
Makes sense.
Any more comments from anybody on the panel? Okay, I'm going to ask the question first, and then we have 3 people waiting for questions. Dr. Kerr, I was going to ask you, on your last slide, you said there's 3 likely components of a systems theory of cancer. One is a disturbance of family homeostasis, which I was thinking of as individuality or togetherness forces. Another is a disturbance in body homeostasis. And the other one was emotional regression fueled by chronic anxiety. And I was wondering what you meant by emotional regression fueled by chronic anxiety. How is that different than, I think you're saying something more than disturbance in the family homeostasis, but I was wondering what your thinking is about that.
Well, I'm thinking that chronic anxiety, which increases in a regression, is the fuel that powers how it plays out by maybe I don't know the answer to your question.
Well, I'll let you think about that, and you can email me with your answer. Okay, I'm going to open it up to the audience discussion. And Nicholson, you're in there first.
Muted.
We can't hear you. Okay.
Okay. Can you hear me now?
Yep.
Yes.
Okay. So this is a real privilege to be here, and I certainly want to thank both of you for the quality of your thinking. And I know I'm going to have a lot of questions for Dr. Bartolosa by tomorrow. But Mike's thinking I have been following over 40 years. And it is just really wonderful to think about how that has evolved in that period of time and the contributions you have made, not only to my thinking, but I think to many others. And one of the thoughts I had about this morning's presentation is that systems thinking, either in terms of biology or in terms of the family, really does offer a balanced view of cancer. And, you know, it's not as simple as fighting the bad guys. And whether we're talking about Ukraine and Russia, or fights in a family, or biology and cells. But it brought to mind my sister, who had cancer, ovarian cancer. And in the 5 years that she was dealing with that, she would say to me, cancer isn't all bad. And I think it had to do with her evolving in many ways during that time period. And the way she approached art became very different. And from what she had done earlier. So I have this wonderful painting in my living room, which is a canvas filled with multicolored flip-flops. And I thought, you know, I just flipped out myself when I saw it. So she gave it to me for a Christmas present. And there's something about that, what goes into lightening up about the problems we face. And all of us can end up in a mess. And it's really about how you think about it. And that's what allows you to do something different. So I so appreciate this, and thank you so much for the entire opportunity.
Okay, thank
And
you.
I should unmute if I can find my way here.
Do it for you, Ann. It's okay. I know how to mute people.
That's what I like. Somebody to do it for me.
Thank you so much. I'm going to mute you now. Okay, Kathleen.
Okay, Ms. Kerr, did you have a comment?
Yeah, well, I'd like to draft on Ann's comment, because I would say I've had the good fortune in my over 50 years of it trying to apply Bowen theory to my own functioning within my family system, my attempts to be a good clinician, etc., of having what could be called bumps in the road of symptoms developing in persons in my nuclear family or in myself that could be regarded as horrible, and which became gifts to make me rethink the way that I understood, to change my epistemology about myself and my family, and to rethink it in a way that was extremely mind expanding and useful. So I oftentimes think that a serious symptom, especially one that's even, I would say even terminal. I have known some people with terminal diagnoses that did not evade the death, but in which the symptom was such a stimulus to rethink things and change things that they died in a very different place than they were when they developed the symptom. So I think the idea of a symptom as a gift / wake-up call is a more neutral way to think about symptoms.
Okay, anybody else on the panel? Comment?
Well, I definitely agree with that. Some people have heard me talk about Jeffrey Rediger's book Cured, and it was just so interesting. People in a real jam who were able to come out of it and how they didn't or weren't able to. And the ones, everybody did something different. The one thing he emphasized in the book as a whole was probably the most important. It was what he called identity, and some realization on a person's part that they really weren't living their life the way they thought they were and needed to make changes, and that cancer was a wake-up call. I call that the gift of cancer sometimes.
Okay, let's move on to the next person. I think that's Mr. Frost in there. It's dark. Is that who it is?
That's him.
Okay, we've got the Kerr's name. You have a question
I
or a
helped him
comment?
get into the meeting, Joan.
What? Oh, okay.
Because I sent him my link. So he's my doppelganger.
Okay.
Yes, I'll just add to the appreciation others have voiced for this conference. I think it's on its way to being a real landmark.